So, you survived presentation 13. Now we start with presentation 14. And here we're going to look at, as promised, at an application of the 7 basic quality management tools. Just to remind you, the 7 basic tools are the check sheet, the scatter diagram, the cause and effect diagram. We have the Pareto diagram, the flow chart, the histogram, and the control chart. We will look at some applications of these different basic tools so you have an idea how to apply them. Our first application starts with testing. We start from a tally, we go to a histogram, and then finally we arrive at the Pareto diagram. I looked at different places. I have different processes that I considered or errors that I found. So place 1, 2, 3, and 4. And the errors are A to E. And we see every stripe corresponds with one incident. And I made a total on the bottom. So over the certain time period and the 4 places, I found 10 errors related to A, 12 to B, 6 to C, 25 to D, and 8 to E. So when we bring this in a Pareto diagram, we see that we have A, B, C, E, D, and E in the order from A to E. So there is just that order that we have selected. And we see that we have a mode with this D. D is the problem or the element we identified with the highest incidence. Now, another thing what we can do is order these data from high to low. So we get a different diagram and we find here D at the first place, then B, A, E, and C. This is the way we can start building basically the Pareto diagram by creating the cumulative diagram of this. So the first element would be 25, then we have 25 plus 12, and so on. And we find, in fact, the Pareto diagram like this. So we have the 25, we always add those elements, and at the top we have the total of all the errors that we detected. We can continue or we can connect it with a line, so we see how this happens. And what we're going to do now is to start remediating. We found the problem which has the highest probability, the highest number of incidents. So we take D, and we have to do something about this. Now, this is the situation that we have. We have the basic situation, the 100% is the total of all the errors. And now we're going to have an improvement. Just imagine we reduce the incidence of D from 25 to 5. So now we create a new diagram, and we see now that 12 is the highest number, then 10, 8, 6, and 5. And D went to the last position. So it's the lowest probability now. Now what we see, what we have now, all these errors together still count for 100%, but we have basically an improvement with 20 items. 20 items were removed from the total. Now the next question is also what next? So the next step to do when we identify this is to look again at the problem with the highest probability. And this is now the item which is 12, which is B. We do this, and then we continue again. And that's the continuous improvement that we are doing using the tally, the histogram, and the Pareto diagram. Another element that I mentioned is the cause and effect diagram, or the Ishikawa fishbone diagram. There are different models that you can make. Here I have an example I found somewhere. I don't know where I found it. It was somewhere in my documents. And I look at poor quality, and we can see at the environment, for example, the working conditions, the raw materials, the management, the workers or the people, the machine, the technology, different elements that we can see that could create to poor quality products. So we're just thinking about what are the possibilities. For example, the workers, they may have educational qualifications, so education is a part, work experience, certification, their behavior at work may be there, their abilities may have an impact on what they are doing, the machines themselves, the operating conditions, the stability, the operation itself, the tool set, all kinds of elements that we can identify. And there are thousands of fishbone diagrams that exist on the internet that you can use. You can create the ones for your company, and it will be the possibility to see or adjust it to your specific situation. It gives you an idea to identify what can go wrong, and it's easy to work from it and improve it constantly. So it doesn't have to be perfect from the beginning, but you can find a lot of examples, so you can already start from a very interesting model. Another element which I refer to are the scatter charts. Here I'm looking at the relationship between the process speed and the error rate or the standard deviation. It's clear that there is a link between the two, so a correlation doesn't always mean that there is a causal relationship. In this element, I can say there is probably a causal relationship. Here we have a positive relationship, so we can replace the dots by a line, an increasing line, or a decreasing, a negative relation, or no relationship at all. So when we don't find any elements that we can compare to. Now we also have flowcharts. We have flowcharts which are very interesting to show processes. Here I made a flowchart for my courses when people can buy an online course, and first of all you look at the course, you add the course to the cart, and the next question is, do you want to buy more courses? You go back to the shop or not. So yes, we add another course. We don't want to add more courses, so we have to open the cart. Then we have to ask the questions, do you have a coupon? Yes or no. If you have a coupon, you have to add the coupon before you buy the course. And when you buy the course, when you don't have a coupon, you directly go to buying the course. You have to add some personal data because we have to invoice. Are those data complete? No, we have to continue that, or we be sure that all the data that we need have been entered. When the data are complete, we pay the course, and of course we store the data in our system. We have data management where we can see what the people bought. We can see what their status is in the different courses. And of course we send a registration email. Now, when we pay the course, we already have the data stored. We have the registration email. Well, it depends. Did they pay? If they didn't pay, we may have to send a payment reminder. We have to wait for the payment, and we have to verify. And once the course has been paid, there are two actions to do. First of all, we will send out the invoice that the course has been paid, and we redirect to the course or to the courses, and the process ends here. So that's a flow chart that we can have. We can do this for certain processes, and it gives us immediately an idea also what we have to program, what are the steps that we have to program in our LMS system to be able to buy the courses, and we can do that for even more complex programs and so on. The last thing that I want to look at are the control charts. I will only show you one control chart. We also relate it here to statistical process control, and the statistical process control is in fact the tool that we are using to create those control charts. And a control chart is composed of an upper control limit and a lower control limit. And the borders between those two are in fact Six Sigma. It's the average, is the dotted line. The upper control limit is the average plus 3 standard deviations at the top. And the lower control limit is the same, but 3 standard deviations minus below the average. And here we see a control chart which is basically in control, and we can see that because the sample averages are spread around the average, and that's the process that we want to have. So that was the application of the 7 basic tools. You have an idea how to work with them. We will look into the control charts deeper later in this chapter. Thank you for your attention, and I'm looking forward to seeing you in our next video. Bye-bye.